Functions, part 2, point 11, handling nil in function return. Sometimes the parameter we provide to function can be nil, or maybe will not exist, or maybe will be empty, like for instance array, and then we have to handle somehow situation when the return value would be nil. And to do it in very efficient way is to predict a situation, like for instance for this function used before, get average sum, we take as parameter array with float values and we return some tuple, but this is not just tuple, this would be optional tuple. It means if everything is okay, it will be tuple, but if not, if array is empty, we will return nil. And in such case, as we can see, this function just takes array and produce sum of everything. And this is second part of our tuple. The first part is just average. And we have our function here. This is just empty array with float values. That is no values. So this array is empty, and result, as we can see, is nil, because this function takes array which is empty array. So if array is empty, this function returns nil. So this is obviously working. If we try to build this array and to add some values, now instead of 0 elements we have 2 elements. There are float values, and we can see we have something here, print optional. This result, this is average, and this is sum of the numbers, values from array. So this is obviously working. You can see it. This function now can handle both situation with array is empty and if array has some values. We use optional tuple. But how to get rid of this optional? We can unwrap the tuple, and now we'll get clean result. So this way we can, in very elegant way, handle situation when there is nil value for, in this case, for our input parameter. Point 12, variadic parameters. It means variable number of parameters. Let's say we have some function and it takes as parameter initial value, and there will be other numbers, but we don't know exactly how many of them. It's just difficult to predict. Maybe there will be 1, maybe 10, maybe 15. We just don't know. It depends. And this function returns just integer. But what we know is that there will be numbers and the type is integer. If we are unable to predict how many of them will be as parameters, after the type we place 3 dots. It means the number of parameters here is unpredictable. We don't know exactly how many of them will be here. So after data type we place 3 dots. We know it will be type integer. And in this function what we can see is variable sum equals 0. What we want to do is to add all the numbers and return their, and at the last stage multiply the sum by the initial value, this parameter here. So obviously we have to add all the numbers, and we treat this parameter name as array name. For number in numbers, we treat all this stuff as array of values, and we just produce sum of them, and then we multiply by initial value. So basically all this stuff is treated like array, and it should be placed as the last parameter in a list of parameters. This should be the last one to avoid confusion. And obviously what we get here will be integer. And now we can see how it's working. Add them all. Initial value. This is our first value here. This is this one. And here we have unpredictable variable number of parameters. And we add them and multiply by 6. This is our variable number of parameters. And this is our initial value. We add all the numbers here and multiply by 6 according to prescription in this place. We can add more parameters. And as we can see, result is modified accordingly. The sum is now 126. So it means it's just working. And obviously the data type could be different here. The point is this parameter, this kind of parameter should be placed as the last one. And we call the situation that we use variadic parameters or variadic functions. Point 13, constant and variable parameters. By default, the parameter in function, this function is change value. I mean, this is the name of the function. By default, we cannot change value of parameter. This function takes parameter which is integer and returns integer. If we try to modify parameter of function, let's say just increment it by 1, we will get error. Cannot be applied to operand of type. It's just we cannot do it because parameter for function, it just cannot be modified. So we cannot do this. But if you would like to do it, we need to do some modification. We need to add var because of variable. Now function knows that this parameter can be modified and we have no error here. Previously it was error. Now we can modify our parameter. If you would like to modify whatever our parameter, before this parameter we have to place var, which means now this parameter can be variable. Point 14, function type. Actually, functions behave more like classes. And let's say this very simple function. What is important here is this part. It means this is a kind of signature for function. It takes two parameters of integer type and returns one integer number. What it does is just adds numbers, nothing special, add numbers, produces 3, this is okay. And it means that this function type, because this function type, we can have several different types here inside, different types for parameters and different returns types. But function type is this part here. It means types of parameters and return types. And we can write it in this semi-graphical way. This is function type for this our function. For this function, when it takes this function takes no parameters and returns void, it returns nothing. This is the type of this function. No parameters taken and no values returned. And here we have something like data function type working. How we can use it? We can, for instance, declare new variable which is of this type, and this is for function print hello. Function print hello has this type, and we define some variable of this type and we assign this function to this variable. It means now this variable can do everything exactly the same way what this function can do. We don't use here parentheses. So printing function now does exactly what print hello can do. So printing function is now it's working. It just produced hello on screen. We can see it here, so it's working. So other words, this is the name of our function. This is the signature or type of this function, and this is our variable which starts to be function and with this type. It's a bit weird but can be useful. Point 15, we could as well to pass function as parameter type to another function, and this is example print result. It takes function, just add function, which is we use it not, it is just the whatever name, internal name, local name here, but this function we will use as parameter. This first parameter, second parameter, third parameter. First parameter is function, some function which takes two integers and return integer value. And what this print result function does, it prints on console this function with parameters a and b, because this function add function, it needs two parameters, and we take the two parameters here from this print result function. And what we can see as add function, we could use different name here because this local name. I use function add numbers because this function add numbers takes two integers and return one integer, which is exactly what I need as a type for first parameter function here. So I just take this function and it returns sum of the parameters. So I take this function here. What it will do, this function will take this function to add the two numbers here, which are two parameters for print result function. This function will take the values here to produce the sum. It can look a bit weird, but it would be very useful as well. Point 16, we could return function as a value from another function. And for instance, we could do it this way. We have some function create accumulator. It takes no parameters, but it can return function. It can return function which is very special because it takes as parameter integer array and returns number which is integer. So this function returns function which takes integer array and returns number. And inside this function, what we have is get sum. It means function get sum takes array integer and returns integer number. And what we have here is we would like to produce sum for this array. We take all values, all numbers in this array and just add them. We start with sum equals 0. This function as such, it returns just sum of the all values in array, but the create accumulator function itself, it returns not the sum, but it returns this function without parentheses here. And to check that it's working, we declare some array, this array of integers, and now we declare accumulator, and it will be, we assign this our function, but this function, as we know, what it does, it produces output, which is some kind of value, which is this function. So it means accumulator is in fact this function get sum. It will take array to produce sum of items in array. So it will take this array here to do what is exactly defined here, because this function will return get sum. It returns get sum. So this function here, accumulator, will add all numbers in array according to this prescription, and we can see it's exactly working. Last point, 17, generic functions are some way of declaration of function, because sometimes function needs to have very specific data type, and if we try to use different data type, let's say we try to use float instead of integer, function will not work, and we will need to write definition of another function which uses float, for instance, instead of integer. To pass it by somehow, we have special construction func, this is function, and now the name of the function. This is simple for data type. Let's say it will take just numbers. Variable number of this parameter means variable number of this data type. Can be integers or can be several floats, several doubles, and this function will return array. So it means it will take some numbers and will produce array of these numbers. And inside we define array, initialize it, and we take the numbers, this variadic function, from this parenthesis. We don't know how many numbers, but whatever number of numbers is inside, we append them to this array, and we return this array. And now it basically works for array of integers, and it works as well for array of floats.